Okay, we're going to look at the discriminant. Discriminant is something that you looked at from National 5. The discriminant is part of the quadratic formula. It's b squared minus 4ac. So just a quick reminder, b squared minus 4ac, when that's greater than 0, that means that roots are real and distinct. When b squared minus 4ac, the discriminant, is equal to 0, that means roots are real and equal. So let's make sure we've got this down. And when the discriminant is less than 0, that means that the roots are non-real. Okay. Now, if the discriminant is b squared minus 4ac is greater or equal to 0, we need to kind of hedge our bets there. So we don't know if it's greater than or equal to 0, we just know it's one or the other. Okay, so if it's greater than equal to 0, what we can say there is that the roots are real. That's all we can say. Now, how can we definitely say that? Well, if the discriminant is greater than 0, we know that the roots are real and distinct, and if it's equal to 0, we know that they're real and equal. So we don't know if they're distinct because we don't know if it's greater than equal to 0. We don't know if they're equal because we don't know if it's equal to 0. We just know it's one or the other. Now, if it's one or the other, the only thing that we can say is the thing that's in both lists, which is that the roots are real. So you just need to learn them off by heart. Okay. So when the discriminant is greater than 0, roots are real and distinct. Equal to 0, the roots are real and equal. And when the discriminant is less than 0, the roots are non-real. And if it's greater than equal to 0, the roots are all you can say that it's real. Now, what does that mean? Well, the roots, remember, are where the thing cuts the x-axis. So real and distinct means that they're real and different. So you're getting two answers. Real and equal means you're just getting the one answer, which would look like that. And if the roots are non-real, then we don't have any roots at all. And that might look like that. So that's a kind of diagrammatical representation of these. Okay. Now, you can tell one of these questions a mile off because it asks you to state the nature of the roots. So we're going to state the nature of the roots. That means calculate the discriminant and make a statement, one of these ones. Okay, state the nature of the roots for, well, let's go A, 3x squared plus 4x plus 5. Okay, so my first move is to identify A, B, and C. A is 3, B is 4, C is 5. Next move, b squared minus 4ac. So b squared, that's 4 squared minus 4 times a, which is 3, times c, which is 5. 4 squared is 16. And then it's minus, well, 4 times 3 is 12, and 12 times 5 is 60. 16 take away 60 is minus 44. Okay, that's a negative result. So minus 44 is less than 0, which means d is less than 0, which means therefore roots are non-real. Okay, example 2. We've got 4x squared plus 5x minus 1 equals 0. A is 4, B is 5, C is minus 1. B squared minus 4ac, 5 squared minus 4 times a, which is 4 times c, which is minus 1. 5 squared is 25. Just take your time here. Minus 4 times 4 is minus 16. Minus 16 times minus 1 is plus 16. That's 41. 41 is greater than 0. D is greater than 0. Therefore, roots are real and distinct. Okay, example 3. Okay, 4x squared is equal to 3x plus 1. Okay, now the first thing that you need to do, just let's solve a quadratic equation. It's the same with problems with discriminant. we need to make the thing equal to 0, so let's bring them over. 3x becomes minus 3x and 1 becomes minus 1, that's equal to 0. And now identify A, B and C. Okay, so A is equal to 4, B is equal to minus 3 and C is equal to minus 1. Okay, so B squared minus 4AC, B's minus 3, so it's minus 3 all squared, minus 4 times A, which is 4 times C, which is minus 1. Just be careful, minus 3 squared is 9. Minus 4 times 4 is minus 16. Minus 16 times minus 1 is plus 16. 9 plus 16 is 25. 25 is greater than 0. D is greater than 0. Therefore, roots are real and distinct. Okay, let's try another one. Example 4. Minus 3x squared equals minus 3x minus 5. Okay, need to make it equal to 0, bring that stuff across. Minus 3x squared plus 3x plus 5 equals 0. A is minus 3, B is 3, C is 5. Okay, B squared minus 4AC. Okay, so B squared, that's 3 squared minus 4 times A, which is minus 3, get that in a bracket, times C, which is 5, 3 squared is 9, minus 4 times minus 3 is plus 12, 12 times 5 is 60. Try and not use a calculator with these ones because they're really not calculator questions. 69 is greater than 0, D is greater than 0, therefore roots are real and distinct. Okay, example 5. X squared is equal to 6x minus 9. Okay, bring these across, make it equal to 0. X squared minus 6x plus 9 equals 0. A is 1, B is minus 6, C is 9. Okay, so A is 1, B is minus 6, C is 9. Okay, B squared minus 4AC minus 6 squared minus 4 times 1 times 9, minus 6 squared is 36, minus 4 times 1 is minus 4, minus 4 times 9 is minus 36, that's equal to 0. D equals 0, therefore roots are real and equal. Okay, so for tomorrow, take your time, watch out for your signs, have a go at those, and we'll pick that up